I keep hearing the phrase autonomous networking tossed around, but it's always tied to AI. Dale, why is AI such a make or break ingredient on this journey to autonomous networks? Isn't automation enough on its own?
Actually, automation is a huge step, sure, but it only gets you so far if the system can't understand what's truly happening in real time. AI brings intelligence and adaptability, but the catch is, for AI to be trustworthy and genuinely useful in these networks, it needs to be smarter, more accurate, and, above all, more transparent. And that's where knowledge comes in.
So it's not just about machines doing tasks. It's about them understanding and explaining their actions. That makes sense. But how does knowledge really fit into making AI smarter in this context?
Great question. Think of knowledge as the backbone the context AI relies on. The smarter the knowledge base, the better the AI can spot issues before users even notice, recommend real fixes, and learn from every situation. I've seen it firsthand with network providers who went from constant firefighting to proactive problem solving after adding knowledge-driven AI.
Hearing about proactive solutions reminds me, can you share some concrete examples? What have you seen when large telecoms put this approach into action?
Absolutely. Let's start with a US internet service provider who was rolling out new digital services. They were slammed with unhappy customers and mystery outages. After deploying our AI and knowledge-driven platform, we managed to cut incidents by 65% within 90 days. Even better, they caught 90% of issues before customers ever noticed.
That's a huge improvement. Did you see similar wins elsewhere, say, with bigger players or in other parts of the world?
Definitely the largest US carrier used the system to pinpoint root causes of customer care issues. By correlating service events with infrastructure problems, they eliminated 250,000 unnecessary technical visits a year. That's about 20 million saved annually. And with a Fortune 200 mobile carrier, we accelerated their 5G rollout by up to 3 months just by building in assurance from the ground up.
Those are huge numbers. It sounds like these projects scale up incredibly fast. Does that present extra complexity?
It absolutely does. We're talking petabytes of data daily, monitoring hundreds of millions of devices and handling thousands of network changes a day. The only way to tame that complexity is by layering intelligence knowledge on top of all that raw data.
All right, let's go a bit deeper. When a telecom wants to start this journey, where do they even begin? Is it all about AI right away? Or are there basic steps first?
Funny you ask, everyone wants to jump to AI. But you can't skip observability. The first step is really about bringing together every bit of data from every tech stack and network layer. You need to see everything before you can analyze or automate anything.
So you're saying observability is like laying the foundation. Once everything's visible, what are the next steps?
Exactly. Once you have full observability, you move to analytics, anomaly detection, cross-correlation, root cause analysis, and suggesting fixes. Here's where AI, guided by rich knowledge, can start making predictions, linking incidents, and even recommending solutions. Ultimately, you get to intelligent automation, so the system can fix issues itself or suggest actions to people.
That loop sounds powerful, especially with feedback learning from what worked and what didn't. Is that how you keep improving outcomes over time?
Right on. Every time the AI makes a recommendation, you feed back the results. Was it the right fix or not? The system continuously learns, making each iteration smarter and more reliable. That's what turns a good network into an exceptional, nearly autonomous one.
Let's crack open that idea of knowledge. What are we actually talking about? Is it just documentation or something more dynamic?
I love this question. Knowledge, in this context, is structured information, human and machine readable. Often, we use formats like RDF, and we visualize it as knowledge graphs. These graphs show not just what's in your network, but how everything connects and depends on each other, including both static and dynamically learned relationships.
So you're not just mapping what you already know, but also uncovering hidden dependencies, like finding that a service actually relies on some component no one realized?
Exactly. Especially in virtualized environments, those links change quickly and often aren't documented. By mining telemetry, trouble tickets, and even chats from field agents, you can enrich the knowledge graph with real-world cause and effect data and context like environmental factors or recurring symptoms.
That sounds like detective work, pulling clues from everywhere. How does all this knowledge actually improve the AI's decisions?
Here's the magic. When you feed this knowledge into your AI agents, you're breaking down silos. Now, if one agent learns something new, that insight can help every other agent reason better. It's like giving the whole team a shared memory instead of experiences. It also means the AI can explain its recommendations and reasoning to humans, which is key for trust.
You've mentioned knowledge graphs a lot. Could you walk us through a concrete scenario, maybe something like a 5G network hiccup you've seen?
Let me paint a quick picture. Imagine a 5G network where suddenly several routers in a region go red faults, are lighting up, but they look disconnected on the surface. The inventory system says they're unrelated, but when we add layers, discovered dependencies, or patterns we've mined from live data, suddenly it turns out they're all linked through one cell site router.
So what looked like three separate issues was actually one root cause hiding in plain sight.
Exactly. And it gets better. If you add diagnostic knowledge like known failure symptoms and layer in environmental data, maybe you notice the router is overheating during a heat wave. The AI, using the knowledge graph, can piece together these clues and not only pinpoint the faulty router, but explain the reasoning step by step. That's a game changer.
That's so much more actionable than a black box answer. And I'm guessing when you scale that across thousands of devices, you really need this clarity.
Without question. At that scale, you're dealing with thousands of overlapping incidents every minute. Only by combining all this knowledge can you make sense of chaos, act quickly, and actually trust what the AI is telling you.
Bringing it all together, it sounds like knowledge isn't just a technical add-on. It's what makes AI and telecom actually trustworthy and understandable. What's at stake if companies skip this step?
Honestly, if you skip out on knowledge, your AI becomes a black box, hard to trust, and easy to get wrong answers, especially as networks get more complex. But with structured, shareable knowledge, AI can walk you through its logic, stay within guardrails, and even let humans verify or challenge its decisions. That's critical not just for performance, but for trust and accountability.
And that's what's going to separate the resilient networks from all the rest. Dale, thanks for unraveling this with us. For anyone curious, where can they see these knowledge-driven tools in action?
Glad you asked. We're showcasing live demos both at small scales and massive network levels. Plus, if you want to go deeper into intelligent agent architectures, Charlotte Patrick will be around sharing some exciting new research. Stop by and see how knowledge can transform AI from mysterious to meaningful.